In the next set of questions, we'll be looking at compound inequalities, and we'll also look at equations involving absolute value and inequalities involving absolute value. Solve and graph each solution set. We have the compound inequality -5 is less than 4x plus 1, and 4x plus 1 is less than or equal to 3. When written like this, we can solve for x, get x by itself, in between the inequality symbols, and we can do the same thing to this part, and this part of this compound inequality. For example, I can subtract 1 from here, and from here, and from here. That gives me -6 is less than 4x, which is less than or equal to 2. And that's subtracting 1 from all three parts of the inequality. Now I can divide everything by 4 in order to get x by itself. I have -6/4 is less than x, and x is less than or equal to 2/4. And these can both be simplified to give me -3/2 is less than x, and x is less than or equal to 1/2. So I can graph this on a number line by marking off a point for -3/2 and 1 for 1/2, and then shading in the numbers between these two numbers, not including -3/2 because the symbol is less than, but including 1/2 because the symbol is less than or equal to. So I use a parenthesis here, a bracket at the 1/2, and I shade in the numbers between them. So the solution set in set-builder notation is the set of all x such that -3/2 is less than x, and x is less than or equal to 1/2. Or, to use interval notation, it's the interval between -3/2, not including 3/2, and 1/2, but including 1/2.